What's the city? I never heard of that.
We are number one.
So you're going on YouTube now?
Yeah. Oh, trick-or-treaters are here too. Alright. If you want, if you can spare like 3 to 5 minutes, they can watch the prize experiment. Come on in, little ones. Don't knock over the little ones, alright? Come on in, little ones. Alright, y'all's area is right here, okay? Stand right there, okay?
Look at him.
Let me get your candy first.
We're about to be rich. Never run. It's the pro board game.
Yeah, and Davis' class, just come in and stand where you can see. No, it's just for the little ones and for my people coming out of the house later.
We have 5 today. They might have told you more, but we only have 5. They've already came out. Here's the baby. We don't know.
I turned some girl into some orange. She used to be all like a beautiful orange. Now she's like, she has a big nose and a big forehead and like small eyes. Her like lips are like, it's retired. Oh my eyes, man.
There you go. Throw that away. Did you get the plate?
I don't even know how to I got Pikachu.
Alright, run the second one. Shut up and dry.
I got this shit. He has dry eyes. All I got was it's no, it's red eyes. He's like this.
Okay, listen up, everybody, even little ones and bigger ones. Alright, a couple of cool things we're going to do. Somebody else throw that away for me too, okay? Actually, keep that one. I'll take that as the carry home bag in case I need it. Alright, so we're going to do a couple of different things with dry ice. Some scary experiments and some cool looking experiments, alright? Alright, so first. Okay. Alright, couple things on dry ice. Man, I'm not cutting it. Alright, when dry ice does this, which first of all, before you go, oh, it's changing from solid into gas, you're alright, but that you're not actually seeing the gas, because what is dry ice again? It's what? What chemical? Solid what?
Nitrogen.
Carbon dioxide. Alright, so all dry ice is solid carbon dioxide. So it's going from solid directly to gas. Now when you see the smoke coming off of it or the fog, that's not actually the gas you're seeing. That's the cold gas you're not seeing that's invisible hitting the water vapor in the air. So you're actually seeing the water vapor in the air kind of poof as it gets cold real quick, right, or condensed real quick. Alright? Now, is this a physical or chemical change?
Chemical.
It's physical because it's still dry ice, right? It's just in gas form now. It didn't combine with technically anything when it's just sitting there. Alright, now listen. Now dry ice, when it's going from solid to a gas, is a process called, listen, junior high, called sublimation. That's kind of like evaporation, but it skips, instead of just going from liquid to gas, it goes straight from solid to gas, and it skips the liquid phase. You can get carbon dioxide to be a liquid, but you have to kind of get it at a special temperature and keep it right there, and it's very unstable. So that's why it goes for us from solid to right to gas. The other cool thing about it, let me get a slightly bigger piece, is, well, you can kind of hear it right there. It gives off a lot of energy when it's changing state, when it's going from solid to gas, so much so that you can actually hear it screech against metal and stuff like that. So that's actually the vibration of the particles of the air and stuff as it's going from solid to a gas. Alright, now the cool experiment. Alright, so that was all physical change. Now, when you add it to water, it's still got a physical change going on, but at the same time, the actual carbon dioxide is combining with the water, and it's forming carbonic acid. If it formed something new, is that chemical or physical? Okay, so in the water it's chemical. Outside the water it's physical. Now when you get the cool smoke effect, which we're all going to see here in a second, that is not chemical. You think it is, but that's actually physical from the cold coming up, hitting the water vapor. So when you see dry ice fog, you're not actually seeing a dry ice. You're seeing water vapor that is condensed by the dry ice. Okay, everybody understand that? All right, so when you see the smoke, all that is water vapor that's quickly being condensed into a mini cloud. And that's what you see. All right, now the fun stuff. I see you. All right. Throw this one in here. And it is very cold, so that's why I'm using either gloves or the tongs. It's like minus 108 degrees Fahrenheit, about minus 8 degrees Celsius, so extremely cold. All right, so as you can see, when we put it into the water, too big of a chunk. Actually, if you get too much, it doesn't work as well. So, all right, so.
You sound like a
all right, now. Okay, in this one, we've just got dry ice and water. In this one, I'm going to put dry ice, water, and soap. It gives you an interesting effect. But to prove to you, so I'm going to do one thing that's a chemical reaction while we're doing all this other cool stuff. All right, in here, it's just water. I'm going to add a little bit of ammonia. It's just like household cleaner. Stinks, but I'm only going to do a little bit, so you won't smell it much. Okay? We're going to add a pH indicator, which is just a substance that when you add it, it changes things color if they're a different pH than water. So we get that effect. Alright. So we got a color change there. Now watch, to prove to you that this is a chemical reaction, we're going to put some dry ice in there. Watch what happens over time. So while we're doing all this stuff, kind of periodically look over there, and you'll see what happens to that one. Okay? So, dry ice. Alright.
No, it's
Now,
boring.
here's the cool thing. The reason why you can put your hand right here and you're not like, burned by the cold or get frostbite is because even though that's negative 100 degrees Fahrenheit, when it hits the water vapor, it kind of reverses the process. That's going adding heat back into it, so it kind of cancels out. That's why you put your hand right here and you might feel a little bit of cold, but you're not like, oh, it's so cold, because it's been canceled out by the other process above the water, okay? All right, now the other cool thing to do is when you're producing a gas from that dry ice, you can also take soap or something that has soap on it, and if you're good enough, and I am every now and then, I'm not going to say it's every time, you can form a bubble.
Teacher, I know what's gonna do. Everybody knows what's going on.
Yeah, look like interesting. I don't see YouTube.
Oh, right at the end. That's the hardest part, is got to take the thing out.
They're trying to candy. I got a Twix. The color changed. I got a rock.
Yeah, if you're looking at the color change on that one over there.
I got a rock. You got a rock? Yeah, right down.
So blurry.
I got a shoe. I got a rock. I got a shoe.
By the way, they sell, as long as I don't sell to kids, but they sell dry ice at Brookshire, so if your parents or anything want to do any of these experiments, then they can also. So right now, we've got a soap bubble that is trapping that gas, and then, I know y'all about to leave, but last kind of cool thing, you can add soap to a container like this. It's a little thinner, a little skinnier. Add your dry ice in.
Boom.
And you get the bubbling effect, but with your soap bubbles. Now, the cool thing is, I was doing good. Usually it doesn't last that long. The cool thing, and here in a second, I'll let you come by and grab a small amount as long as you don't smack them towards anybody. Yourself, I guess, I'm not including, if you really want to do that, but not towards anybody else. So what's cool is, you can grab these. Remember, they're not super cold because the cold has been canceled out by the heat above it. Now, since that's got dry ice inside the bubbles, when you smack the bubbles,
Makes powder.
then you get carbon dioxide and water vapor. So you see that water vapor cloud that's kind of trapped inside. Okay? All right. So,
Thank you.
no problem. No, go ahead and go. Y'all go enjoy the rest.
Bye bye.
All right, here's the deal. You can swing by, grab a small amount, don't try to take the whole thing, and then go away from other people. If you want to do your smoke bubbles, you can. Not in anybody's face. So I'm also going to put a, I think I got time in this class. All right, sweet. I'm going to put a glow stick. So this is something you can do if you got like a bowl and all this stuff.
Excuse me? Do you know who you're talking to? Yeah, Bryce.
Gonna take a glow stick?
You just took all of it.
You're talking to the guy who doesn't know how to repeat.
That's like how good these glow sticks are. I got a spot in here. Sometimes they're good, sometimes they're not. So we'll see.
Take the bubble.